Hello, my name is Vaidera from Kodarasa. Today we're going to cover database relationships. I hope you learned something and feel free to ask all the questions that come up during this video, during this course. You're welcome. Database relationships. What are they? They're connections between tables in a relational database. These relationships define how data is related to each other between the different tables. They help us with linking the different tables, they help us in organizing the data, and ultimately, the end goal is querying efficiently. So, they do help us with this. Let's look at different types of database relationships. We have a one to one relationship. This is where one record in one table relates to exactly one record in another table. We're going to see an example of this. Another example is many to many. Many records in one table relate to many records in another table. And last but not least, we're going to look at one to many, which is where one record in one table relates to many records in another table. When looking at an entity relationship diagram, if this is a new term for you, please look at the first. I think one of the first two videos I've covered entity relationship diagrams within this course. So feel free to look at it so that you can understand better what I mean when I say entity relationship diagram. In an entity relationship diagram, we have the one side, that is the arrow pointing to the table where, you know, the one side. I'm going to explain that. Basically, if I have a relationship where one table relates exactly to one record, like one record in one table relates to exactly one record in another table, then we'll have a straight line. But when one table relates to many records in another table, that other table will have the prong, the fork. The many side will have that prong, that fork, and the one side will have a straight line. So let's look at an example. We have a student and a student ID card. Let's assume these are two different tables. One is for tracking basically just details on student IDs, and the other one is tracking details pertaining to the student. These are two different tables. Each record in table A corresponds to exactly one record in table B. And you can see the same case in reverse. So when you look at the inverse of that, the same case applies. One record in one table relates to exactly one record in the other table. This is implemented by adding a unique foreign key in one of the tables which references the primary key on the other table. Let's look at an example on an entity relationship diagram. We have a student table with ID, name, and class columns, and we have a student ID card table with registration number, start date, end date, and the student ID. These are two different tables. So the relationship, as you can see, is one straight line pointing at both tables because the relationship is one to one. Let's look at a different one. So, if you went to Kenyan schools like me, I don't know about your country, but this is what we have in Kenya. We have duties as part of the things we do in school. We study, we take part in activities. There could be maths contests, there could be drama club, whatever, and we also do duties as part of the things we need to do. This is basically cleaning up our environment. It can be the dining hall, the classroom, the dormitory, the toilets, and some schools, even pigsties. Depends on your school. Sometimes that's a punishment, other times that's part of your duty. In this case, one duty, for instance, let's look at the dining hall as a duty in itself. One dining hall can be assigned to many students. So many students will get to clean this. But one student is only assigned one duty. During time for duties, my concern is whether the patch have been assigned in the dining hall is clean. And that's my only responsibility. In the duty table, if we look at duty as a table and student as a table, one duty is assigned many students. But we can't say the same in reverse. One student is only assigned one duty. So that is what we call a one to many relationship. Each record in table A can be associated with multiple records in table B, but each record in table B is associated with only one record in table A, as we've seen. This is typically implemented by adding a foreign key in the many table, table B, or whatever you call it, that references the primary key in the one table. That is table A in this case. In our example, the table B here is student and the one table is the duty. Let's look at an entity relationship diagram. We have duty with ID, name, and number of students, and we have student with ID, name, and duty ID. As you can see, the fork is on the student side, and on the duty side, we have the one straight line, implying a one to many, one duty to many students. Let's look at another example. I've mentioned studying, I've mentioned duties. We also do activities in school. You can take part in games, you can take part in different clubs or even contests, whatever you do. There's different activities depending on what the student prefers. You can be in basketball, you can play tennis, you can be in drama club, you can do music. In this case, one activity, let's use drama club as an example. The drama club will have many students, and a student can choose to take part in different things. Maybe at night we have drama club, but in the evening we have, like, I can do hockey, so I can take part in different activities. And not only that, there are activities that are maybe for just one day. Maybe we have a maths contest club or something pertaining a debate club, and that only happens on Tuesdays. That means on the different days they can take part in different activities. So in this case, a student can be assigned many activities. This is a perfect example of a many to many relationship. The student has many activities, the activity has many students. Each record in table A can be associated with multiple records in table B, and each record in table B can be associated with multiple records in table A. To handle many to many relationships, we use a junction table. It can be called a link table, an associative, a bridge table, whatever you want to call it, but basically a joiner table. This table contains foreign keys that reference the primary keys of both table A and table B. So in this case, it will reference both the student ID and the activity ID from the two different tables. Ideally, without the link table, this is what our entity relationship diagram would look like. We will have the activity with the ID, name, and number of students, and we have the student with ID, name, and class, with prongs facing both of them to signify many to many relationships. But this would make querying really difficult. That's where we have a link table. In between the student and the activity, we'll have a student activity table. In this case, we'll have a one to many relationship from activity to the link table to imply one activity is linked to many student activities. So in this case, it won't be a many to many in that prongs fits both tables, but it will be a one from the main tables to the link tables. We're going to see an example of this in an actual entity relationship diagram for this. And we have a bonus. We've covered, so the three main ones are one to one, many to many, and one to many. We have a bonus one where a table self references itself. It's sort of a recursive relationship. Let's look at an example where we would have this. We have an employee with ID, manager ID, and name as the example of our columns. An employees table is where each employee will have a manager who is also an employee in the same table. A manager is also an employee. So it makes sense to query the same table to get details of the manager or maybe the employees under them or maybe two levels above you. We can do all sorts of queries with this. That's a challenge for you. A relationship where a table has a foreign key that references its own primary key, allowing rows within the table to relate to each other. Let's look somehow at the premise of this. How did we get to a place where we do self-referencing? Ideally, if we were to separate the manager and the employee, would have a one to many relationship where one manager has many employees. And that would work if we only had one manager who is the manager of all these employees. But we have a case where this manager also has a manager and the manager has another manager, different levels. So C-suite, senior managers, junior managers, you get the idea according to your organization. And if we were to demonstrate this, then we'd have employee and then maybe another table for lower managers, and then another table for upper managers, and then another one for maybe C-suite managers, depending on the company you're working with. That doesn't look that neat, and it would really be complicated. But you realize that a manager is also an employee. That's why we can now have the manager represented within the employee table. And we're going to see an example of a table with such details. So let's look at an example. We have 5 employees here. ID number one, Karindi, they're not tied to any manager. So we can assume this is maybe a CEO, the highest person in the company, the highest manager. Under them, we have 2 employees. We have ID number two, Mudhamia, and ID number 3, Koroi. They both report to Karendi. And then right below that, we have two more employees. We have Muisoeri, ID number 4, who reports to Nkoroi, ID number 3. And then we have Modangiri, ID number 5, who reports to Modamia. This gives us a representation of the different levels, and when I'm querying, I can easily tell who is the manager of who reports to who. I can even see, give me the next level manager. Maybe I want to send a message to the manager of my manager. I can easily get that information to this. Or maybe you're sending a message and you send to all the managers, but then you feel the need to CC their managers so that there's oversight. Then you can easily get that information. And that's it. And we're lastly going to look at a Lucidchart. So let's see an example of that. We are still using a school management system for this, so we're going to use this as an example for our entity relationship diagram example. We're going to use Lucidchart for this. Lucidchart is an app that helps you create entity relationship diagrams for your database. So a teacher can have many classes. So we have this joiner table between them, teacher class, that has teacher ID and class ID. You can see one-to-many and one-to-many from class to teacher class that we have. I also mentioned duty. So one duty is related to many students. So again, we can see the one-to-many relationship between the duty and the student, and that's how it is represented. Student activity, again, this was a many-to-many relationship, but we have a linkage table, we have a bridge table, and this is how we represent it using our, in an entity relationship diagram. So these are designs that come in handy when you're designing your database for your application. So something to learn. I hope you learned something. That's all for today. And that's it on database relationships. Feel free to leave your questions and I'm going to respond to them. Happy learning. This is from us at Codarasa. I hope to see you again. Bye.